session, we actually have another presentation which is by Professor Mehdi Shakibaei. He is a professor at Institute of Anatomy, University, Munich, Germany, and his area of interest is in inflammation and tumor biology. Professor Mehdi did his PhD from Free University Berlin. He's also was a professor at the Free University of Berlin, and we'll now listen to his recorded seminar. So I request the audience to stick around. Thank you.
Sorry, I cannot be physically there, but I'm very happy to show you some part of my result by this way. First of all, I would like to thank the whole organizing committee for this very well organized Congress, particularly Dr. Alam. The topic of my talk today is multifunctionality of collagen A in inflammation, chronic diseases, and cancer. Inflammation, chronic diseases, and cancer. We know today there is almost no disease that is not directly or indirectly related to inflammation. In other words, there is no way around it in medicine. The main sources of inflammation cause, they are food factors, ultraviolet radiation, environmental pollutants, alcohol abuse, nicotine, microorganisms like bacteria and viruses, stress. They cause inflammation. And this inflammation could cause in every organ itches. We know today every organ can get itches. And when this inflammation gets dysregulated and can get a chronic process, they can develop cancer. Even Ronald Bishop in 18th century talked about inflammation and its association with atherosclerosis, rheumatoid arthritis, multiple sclerosis, asthma, Alzheimer's disease, and cancers. The role of genes environment in the development of cancer, we know today even less than 5% of all cancer cases are caused by genetic defects, and 90 to 95, 98% are caused by environment and lifestyle. It means that there is a great opportunities for cancer prevention. As you see here, among these factors, diet may be the most important environmental factor. Dysregulated chronic inflammation caused by lifestyle factors causes chronic diseases, including cancer. Regarding pathogenesis of cancer, this is genetics and epigenetics. Genetics, it means expression of a genetic disposition or instability, damage of the genetic materials or errors in the reading of the genetic information. Regarding of epigenetics, this is mechanisms that exert a heritable and indirect influence of gene expression without permanently change the DNA sequence. In contrast to genetic alterations, epigenetic changes occur much earlier during cancer initiation and progression. They are potentially reversible, are easily influenced by environmental and dietary factors like weed, fat, smoking, etc. With other words, epigenetic changes due to dietary polyphenols are a new medical approach. We know today the very famous pro-inflammatory transcription factor NF-kappa B is linked to inflammation. It is a pivotal transcription factor in chronic inflammation disease, and we know that NF-kappa B does play a main role in cancer development and progression. Central research principle for most types of inflammation, which means pro-inflammatory environment, cause activation, phosphorylation of a lot of transcription factor and signaling molecule, including NF-kappa B, and they cause inflammation. NF-kappa B we know today regulate at least 500 different genes and genes proteins, which are involved in metastasis, inflammation processes, anti-apoptosis, pro-apoptosis, transcription factors, stress response, proliferation, and cytokines processes. With other words, NF-kappa B is a powerful pro-inflammatory cytokine. Cancer treatment requires suppression of multiple cell signaling survival pathways, inhibition of multiple cellular survival signaling pathways in tumor cells by non-toxic multi-target drugs is essential. For that reason, natural polyphenols are known to exhibit a wide range of anti-tumor, anti-oxidative, anti-inflammatory effects as free radical scavenger inhibition or induction of apoptosis. Cancer is one of the most commonly diagnosed diseases, and its associated mortality is a very significant health problem worldwide. Despite numerous recent improvements in diagnosis and monitoring, the overall survival rate for cancer has not improved. In fact, nearly 50% of cancer patients develop chemoresistance and recurrence, suggesting that available therapies are unable to control this deadly disease. That is the major cause of failure of cancer chemotherapy. With other words, activation of multiple cellular survival signaling pathways, which are activated by tumor cells, is the primary cause of chemoresistance and tumor cell recurrence compared to conventional mono-target therapies. Why is NF-kappa B a good target for development of cancer drugs? Most cancerogens activate NF-kappa B. Tumor cells often produce an activated form of NF-kappa B. Even tumor microenvironment can trigger NF-kappa B activation. NF-kappa activation blocks apoptosis and mediates tumor cell proliferation. NF-kappa B activation leads to resistance to chemotherapeutic agent and gamma radiation. Several genes involved in tumor initiation, promotion, and metastasis are regulated by NF-kappa B. With other words, inhibition of NF-kappa activation suppresses cancerogenesis. Classical tumor treatments, the mono-target therapies, are actually unsafe, ineffective, high recurrence prevalence, and very expensive. Tumor cells are extraordinarily intelligent cells. They develop different chemoresistance pathway. For that reason, we call that multi-drug resistance. They act on more than one mechanism at the same time. Monotarget chemotherapy treatment, you can imagine, cannot fight at the same time against different signaling pathways which are involved in apoptosis, proliferation, recurrence, and metastasis. For that reason, phytopharmaceuticals that modulate multiple cellular targets such as anti-inflammatory, restrict energy, creating an alkaline environment, promote apoptosis, prevent proliferation, maturation, invasion, and therefore they are effective chemosensitizers for tumor cells against conventional therapeutics. Today I'm talking about Calibin A and cancer. Calibin A, its structure from turmeric, is a new curcuminoid isolated from turmeric. Like curcumin, Calibin A can inhibit the tumor cell growth and induce apoptosis in drug-resistant human cancer cells. Last month, they could publish a paper, multifunctionality of Calibin A in inflammation, chronic disease, and cancer. As you see here, we summarized here all transcription factors and signaling pathways which are involved in inflammation and in tumor development are blocked by Calibin A. And Calibin A at the same time is able to inhibit, stimulate caspases. In other papers, we could show Calibin A suppresses NF-kappa B and NF-kappa-mediated proliferation, invasion, and metastasis in CRC cells induced by TNF-beta. As you see here very well, in 3 different CRC cells, Calibin A inhibited proliferation of cells, and even when the cells are stimulated by TNF-beta, are inhibited significantly their proliferation. You can see here very well, Calibin A is able to inhibit significantly the phosphorylation activation from NF-kappa B. Even the cells are activated by TNF-beta, phosphorylation and activation of NF-kappa B is significantly blocked. Even NF-kappa B mediated proteins which are involved in proliferation, invasion, metastasis, like integrin beta-1, CXCR4, NMK9, P67 are blocked, and at the same time, caspase-3 is involved in 3 different CRC cells. And at the same time, when the cells are stimulated by pro-inflammatory cytokines TNF-beta, Calibin A inhibit the mentioned proteins and activate again caspase-3. With other words, NF-kappa B seems to be one of the major target transcription factors for Calibin A. Even as you see here very nicely, Calibin A blocked the interaction between phosphorylated NF-kappa B and DNA. Next paper, we could show more details about the role of NF-kappa B and Calibin A interaction. As you see here, we used in this paper BMS that is very specific EKK inhibitor. We wanted to compare the function of Calibin A with BMC. As you see here very well, the phosphorylation activation of NF-kappa B is dose-dependently inhibited by Calibin A exactly in the same role like BMS. Even proteins they are regulated by NF-kappa B and involved in maturation, metastasis, and proliferation, exactly D1 and D9, they are inhibited. In contrast with that, caspase-3 is activated in the same role like BMS. In this picture, you see here very well the expression of anti-apoptotic genes are inhibited by Calibin A in the same role like BMS, serving BCL2 and BCL-XL. Next paper, we could show Calibin A potentiates the effect of FU and TNF-beta against human CRC cells and the role of NF-kappa B. As you see here very well, TNF-beta stimulate in the same role in normal CRC cells and even in CRC resistant cells. However, in the presence of 5-FU, in normal CRC cells, the proliferation is inhibited, but not in resistant cells. However, the TNF-beta stimulated cells in normal CRC and in resistant cells, in the presence of 5-FU and calibin A, is in the both cells is significantly inhibited. This potentiation between calibin A and 5-FU you see here in regarding of migration. You see here in normal CRC cells as well as in resistant cells, the proliferation, the migration is significantly inhibited. Interestingly, in the presence of 5-FU, the phosphorylation of NF-kappa B is activated dose-dependently in both of cells. However, in the presence of calibin A and in the presence of TNF-beta, the activation of phosphorylation NF-kappa B is blocked very significantly. Again, you see here potentiation as synergistic effect between calibin A and 5-FU. And even in the regarding of expression proteins which are activated by NF-kappa B and involved in migration, proliferation, and metastasis like beta-1 integrin, MMP9, CD4, Ki67 are activated by 5-FU. And as you see here, caspase-3 is inhibited by 5-FU alone. But in the presence of calibin A and TNF-beta, the mentioned proteins are inhibited and caspase-3 is very well activated. The next paper, we could show the AMT and CRC in combination with calibin A treatment. We have used in this paper cyclochalazine D. As you see, cyclochalazine D inhibits cytoskeleton proteins in the cell. We wanted to show calibin A could inhibit cytoskeleton. And as you see here, regarding of migration, dose-dependently, calibin A inhibit migration of the cells like cyclochalazine D in both kinds of cells. And cyclochalazine D is able to inhibit the migration of cells. And we could show here, in the same row, calibin A inhibits phosphorylation of NF-kappa B like cyclochalazine D in both kinds of cells. Phosphorylation activation of FAK, focal activation kinase, which is important for polymerization of cytoskeleton proteins, is inhibited by calibin A like cyclochalazine D. And even the activation of caspase-3 is promoted by calibin A like cyclochalazine D in both kinds of cells. In other words, it seems that the cytoskeleton proteins are the next target proteins for calibin A. We wanted to see the functional cooperation between phosphorylated NF-kappa B and SLAG. SLAG, we know that is very important transcription factor regarding of AMT. And as you see here very well, immunoprecipitated NF-kappa B are linked with SLAG. And calibin A, like cyclochalazine D, are able to inhibit these links. With other words, SLAG is the next targeting molecule for calibin A, and vice versa. When we immunoprecipitate with SLAG and immunoblot with phosphorylated NF-kappa B, we see the same results. The next paper, we could show here, even cancer stem cells are the main target of calibin A. As you see here, stem cell marker ALDH1, CD44, CD133 are down-regulated by calibin A in the presence of dose-dependent. Calibin A has an anti-inflammatory effect through different signaling pathways, as summarized here. And calipin A as anti-cancer agent is able to inhibit different cancer cells, for example, breast cancer cells, CRC as I showed you, gastric cancer, head and neck cancer, hepatic cancer, leukemia, lung cancer, lymphoma, and multiple myeloma. I summarize here again molecular regulatory targets of calipin A regarding of kinases, transcription factors, apoptosis, cancer stem cell biomarker, proliferation, metastasis, EMP biomarker. My last slide, I summarize again, calipin A is able from outside to inhibit, block, even receptor ligand binding, is able to block phosphorylation of NF-kappa B, translocation from NF-kappa B in the nucleus, and even to block the proteins which are involved in inflammatory invasion, metastasis, chemoresistance, and angiogenesis processes. Conclusion: to prevent tumor cells resistance to conventional mono-target chemotherapeutic agents and to chemosensitize tumor cells to chemotherapeutic agents is the initiation of multiple cellular signaling pathway in tumor cells by non-toxic and multi-target drugs is essential. Cancer treatment requires suppression of multiple signaling and cellular pathways. I thank you for your attention, and if you have a question, I would be very glad and happy to get from you by mail your question, and I wish you very nice Congress. Bye-bye.